we can derive a special case of the section formula for when the point P lies exactly between the 2 points which are given. For example, if P lies exactly between these 2 points, then the ratio m is to n becomes 1:1. So in that case, the section formula reduces to the midpoint formula. So if P is the midpoint of the line segment AB, then the coordinates of the point P, the midpoint of the line segment AB, whose endpoint coordinates are x1, y1 and x2, y2, is given by x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. Next, section formula for external division. If the dividing point P lies outside the line segment AB, then the section formula is given by x is equal to m into x2 minus n into x1 divided by m minus n. Y is equal to m into y2 minus n into y1 divided by m minus n. So here AP is given by m and PB is given by n. So that is the ratio of AP is to PB. Given that, the point P's coordinates can be obtained as x is equal to m into x2 minus n into x1 divided by m minus n, and y coordinate as m into y2 minus n into y1 divided by m minus n. Every triangle has 3 or 4 special points. One of the most important of those special points is called the centroid of the triangle. Centroid of a triangle is a point such that from the centroid, if you join to a line segment to the vertices, then 3 triangles inside the original triangle are formed, and each of those triangles has equal area. More formally, the centroid of a triangle is defined as the point of intersection of the medians of the triangle. What are the medians? The medians are line segments joining the vertex of a triangle to the side opposite to the vertex. So the point of intersection of these medians is called the centroid of the triangle. And as I said earlier, it divides the triangle into 3 equal parts. Let us look at how to calculate the coordinates of the centroid of the triangle if the vertices of the triangle are given. Consider a triangle, say A, with coordinates x1, y1, B, x2, y2, and C, x3, y3. Then the coordinates of the centroid of this triangle, most general symbol used for centroid is capital G. So G will be given by the arithmetic mean of the x coordinates, arithmetic mean of the y coordinates. That is x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. Another important point which is related to a triangle is called the incenter. The incenter is the point of intersection of the angle bisectors of a triangle. When you have the incenter and you take a suitable radius, then you can form a circle which touches the 3 sides of a triangle from the inside. That is, you can get a circle to which the 3 sides of a triangle are tangent. If we know the coordinates of the vertices of a triangle and thus we also know the lengths of the sides of a triangle, then there is a very simple formula to calculate the coordinates of the incenter of a triangle. Let's look at that. The coordinates of the incenter of a triangle whose vertices are x1, y1, x2, y2 and x3, y3 is equal to ax1 plus bx2 plus cx3 divided by a plus b plus c, and ay1 plus by2 plus cy3 divided by a plus b plus c. What are a, b and c here? The small a, small b, and small c represent the length of the sides which are opposite to the vertices a, b, and c respectively of the triangle ABC. And thus, knowing the coordinates of the vertices, it is possible to find out the length of sides as well. And thus, the in center of a triangle is given by this neat and symmetric formula.